With SARS-CoV-2 continuing to spread in certain parts of the world, this allows for additional variants to emerge. One of these variants is known as the Lambda variant, which the World Health Organization has classified as a variant of interest. Now, the World Health Organization classifies these variants into two categories: one, variant of interest, and two, variant of concern. Now, variants of interest still need more research done in order to characterize that particular virus. And variants of concern have already had research done that shows one of two things. One, that the virus is able to be more transmissible to other individuals, and or that virus is able to evade some of the antibodies produced from the vaccine or natural immunity. Now, you can think of this like a crime scene. And in the beginning, there's a lot of people of interest. But it's not until the officers are able to collect more evidence, do interviews, and do more research that they're able to narrow down that to just a small group of suspects. And that's what happens when we move from variants of interest to variants of concern. But I still want to break down the biochemistry behind the Lambda variant, which has two novel spike protein mutations. The first occurring at position 452, where leucine has been changed to glutamine, and the second at position 490, where phenylalanine has been changed to serine. And while the charge of these amino acids does not change, unlike the Delta variant, there is another change that does occur, and that's the ability for these amino acids to interact with water. Now, we move from two hydrophobic amino acids, meaning that they repel water, to two hydrophilic amino acids, meaning that they are attracted to water. Now, this can adjust how those spike proteins will come together depending on the environment that they're in. Additionally, if we look at the size of these amino acids, for the first mutation, we move from leucine to glutamine, where the size of that amino acid doesn't change much. However, for the second mutation, we move from phenylalanine to serine, where we lose this large benzene ring. And again, as we adjust the shape of these amino acids, that can adjust the shape of that spike protein and how it's going to interact not only with the ACE2 receptor, which would relate to its transmissibility, but also with the antibodies produced from the vaccine or natural immunity. However, there has been some early research done on the Lambda variant. The first is in a bioRxives paper, which shows that the current vaccines we have are able to neutralize this variant. Additionally, it shows that the Regeneron antibody therapy is also able to work against the Lambda variant. However, it's important to note that this is a preprint and that after it goes through peer review and final publication, it may have some adjustments. Secondly, Public Health England is currently looking into the Lambda variant, and as that research becomes more available, I'll be sure to keep you all informed.